A long but careful way of doing this question would be to construct a grid and just, look at what happens after one move, two moves, three moves, and four moves. And you could, if you have the paper, kind of do it all on the same bit of paper, just maybe use like different symbols to identify it. If possible, I'm going to use a grid here to show it clearly. So after one move, there's only four different locations we could end up in, these four here. After two moves, we could go an extra one out in all of the directions, or we could actually go one to the left or right at the top. I suppose we could consider each one in turn, or we could even go down to the middle. If we end up at this one on the left, we could also go down. Go down here. So these are going to be, I'm not going to count how many these are, but those would be the possible spaces, and that's it, because they're all actually two or zero away from the original in terms of adjacent squares. Right, now I can basically do the same sort of thing again. So I'm again going to get these. We cannot now be on the grey square, for example. Or I could be another two away up here if I'd sort of gone one, two, three. Or you can imagine at this point sort of just moving one up. So I can do, put little dots where all of these are. And that's it, because these are all the squares that are either one away from the original or three away. Which takes us to the very last one, and this is where the kind of the quick idea comes from in. We either want to be 0, 2, or 4 squares away now. So I could go back to the original, or I could go back to all the ones that I had for part 2. That's when the outer ones go back inwards, or actually this one here could just, yeah, move back down. Or remember, I could carry on going to the right from here. So this is four spaces away. I've done all the ones that are 0 away, 2 away, because that was the same as part 2. So now I need all the ones that are 4 away. So I could go here, 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 or here. But I could also imagine sort of moving up like that, which means I can fill in these. So they're all 4 away because I can go up 1 and along 3. And that's going to be it. And in theory, you could just go straight for this pattern straight away if you realize that they can move 0, 2, or 4. So how many different squares could Jack finish? We just need to add these up. I'm going to do this carefully. So we've got 1 in this row, then 2, then 3, then 4, and then 5. And by the symmetry of the problem, I'm also going to get 4, 3, 2, 1 here. So I can add the 4, 3, 2, and the 1 to give 10. I'm just going to double that, 2 times 10, because then that will account for these as well. And then I just add on 1 lot of 5. So after 4 moves, there are 25 possible positions.